Hi class, so we are now down to the ninth out of the 11 improvement tools that we are going to discuss this entire semester. So the ninth improvement tool we have is your OLAP or your Online Analytical Processing tool. So let's begin. So again, OLAP stands for Online Analytical Processing. So O for on, then L for line, then analytical processing. So here are the things that we are going to discuss for OLAP. So we have business intelligence or BI technologies, and then we will be defining what is OLAP, and we are also going to learn what is a data cube and what is a hypercube. And then we are going to familiarize ourselves with the OLAP operations, and then we will get to know the types of OLAP tools. So let's begin with BI or Business Intelligence Technologies. So with the growth in data warehousing, users demand for more powerful access tools that provide advanced analytical capabilities. Now, you may have heard the words data warehousing or data warehouse before. So, without dwelling into the very technical definition of what a data warehouse is, just imagine a warehouse, a physical warehouse. So, what does a warehouse do? It stores something. Warehouse is a storage place. Okay, so when we speak of data warehousing, this is where the data that is being gathered by the company are being stored. Okay, so when we store data in a data warehouse, we are expecting our users or our employees or the members of the organization to retrieve some of the data to be used for decision making, correct? So we need to access some of the data that are being stored in the data warehouse. However, if the data warehouse is so huge and in such a way that many or voluminous data are being stored on a daily basis, it would be hard for us to access or retrieve the type of data that we want to retrieve. So that is why we have a demand for more powerful access tools. So that is your hint, okay? Access tools that would provide advanced analytical capabilities. So what are the two main types of these access tools? So again, we want to access or retrieve data from the data warehouse. So we need tools for faster retrieval or faster access of these data. So the two main types are we have the OLAP and the data mining. So for purposes of performance management system, since that is our course or that is our subject, we will only discuss what is online analytical processing. So we will leave data mining for future discussions. So data warehouse are also called data marts. Okay, marts or like a store, okay, together with tools such as your OLAP and data mining are referred to as business intelligence technologies. So if you have data warehouse on the one hand and you have access tools such as your OLAP or data mining on the other hand, collectively they are referred to as business intelligence term technologies. So what is OLAP then? So aside from spelling out what OLAP stands for, now we all know OLAP stands for Online Analytical Processing. So let's define it so that we would be able to understand it further. So as defined, OLAP is a system that further transforms the data into a more structured or summarized form than tables. So instead of just presenting data in a tabular format, OLAP helps us to capture the data and then think of a better way to present it other than in a tabular format. Okay, so it will transform the data. It will show us the summary of the data that we want to retrieve other than that of a tabular format. Okay, so what is wrong with a table, a tabular format? So tabular format is very much simplified, and it's like a 2D, right? 2D presentation. So in OLAP, we are focused on the 3D or more advanced D versions. Okay, so OLAP looks at data in multi-dimensional form. So normally we look at data using OLAP using a data cube in a data cube presentation. OLAP can be used by multiple users to access data in a data warehouse, example via the internet. So, for example, we have one data warehouse for the entire company. And all, of course, since this is a data warehouse, all the data being captured by our system will be stored in the data warehouse, and we can expect multiple users, multiple persons within our organization who would try to access data coming from the data warehouse. So using OLAP, any one of us in the company can have an access, can retrieve the data that we want to retrieve from the data warehouse. Okay, and then OLAP provides managers with a quick and flexible access to large volume of data. Again, because the managers are expected to make decisions with respect to their area of accountability. So, for example, for a marketing manager, the marketing manager has to make decisions related to marketing, advertising, and sales. So then the use of OLAP will help the marketing manager to make decisions, make good decisions, and not just decisions based on hunch or feelings. Okay, so the data that is being captured by our system, again stored in the data warehouse, will then be retrieved using OLAP and will be presented to example marketing manager in a most useful way other than a table. Okay, so there would be more information that is being presented in the results of the retrieval if we use OLAP. So here is the more formal definition of what is an OLAP. So in 1993, this person named Cod introduced the concept of OLAP, and he defined OLAP this way. So OLAP is the dynamic synthesis, analysis, and consolidation of large volumes of multidimensional data. So OLAP technology uses a multidimensional view of aggregate data to provide quick access to strategic information. So why do we need to use OLAP? Is OLAP necessary? Oh, so if you are a small company, you may want to defer your use of OLAP considering the cost and cost benefit, okay? But if you are a huge corporation, large organization, it is it is very important for you to consider using OLAP. So why is OLAP important? So users, again, as mentioned a while ago, the users need powerful tools for the access and analysis of large volume of data, meaning those data that are stored in the data warehouse. So again, as mentioned a while ago, we have two main types of analysis tools, and these are your online analytical processing and data mining. So for OLAP, this follows a top-down analysis, while data mining uses bottom-up analysis. So later on, we will be able to appreciate why is this OLAP using top-down analysis? Why is this referred to as a top-down analysis? Okay, and what is the benefit of using OLAP as compared to just using a general purpose query tool? So if you use OLAP, OLAP has the ability to answer what if scenarios, and will be able to explain why this is such. Okay, instead of just giving us the answers to our questions of what, for example, um, what is what is the most profitable quarter? So um, when did this sale occur? Where? Where did we have the most number of sales and how much? Let's see, how much is the price per unit? So um, these WH questions, this what, when, where, and how much, these can be addressed by general purpose query tools. However, if you have bigger questions like what if, for example, what if we change our selling price from 10 pesos to 20 pesos, what will happen? And then why? So this gives us a justification or a reason why a certain event has occurred. Okay, so why did we experience loss in the third quarter? Perhaps because we had a shortage in our inventories and we were not able to fulfill the orders of our customers. Okay, so if you want answers to bigger questions, then OLAP is for you. These big questions will not be answered by general purpose query tools, but these will be answered by OLAP. Okay, so granting this one, we could say that OLAP has a more advanced and interactive functionality, such as it allows you to do browsing. uh, the system will also make calculations. Okay, and then the system, the OLAP, will also be able to perform complex analysis. Okay, so let's now apply OLAP. Okay, OLAP applications usually have the following common features. So we have the multi-dimensional views of data. So if we say multi-dimensional view, this is when we view data from various perspectives. Let's say in the perspective of a product, or in the perspective of a per location basis or per time basis, let's say per day, per month, per quarter, per year, etc. And then it also supports complex calculations as mentioned in the previous slide. So what are these complex calculations? Example, OLAP can do sales forecasting for us based on the input, based on the inputs that we have encoded in the system. Thus, the OLAP can help us come up with a reliable sales forecast. And then it can also do moving averages, percentage growth, etc. And then it also has this time intelligence feature. Example, it could compare sales performance between different time periods. So, for example, we want to compare your sales performance in the first quarter with that of the second quarter, or this year versus the previous year. So OLAP can do those things. Okay, so what do we mean by multi-dimensional views of data? So this is the usual presentation of the data that we see. Okay, so this is an example of a two-dimensional view. It's like a normal table, right? So for example, we have here the city, and then time is for quarter one. So for this city, we have these total revenues that we have earned coming from this city. So in quarter one, we have this much of of revenues. In quarter two, quarter three, and quarter four. For London, another city, we have quarter one through quarter four, and then another city from quarter one to quarter four. Okay, so you can show it in this usual table. You could show it this way. Okay, so again, diba, in OLAP, we present information other than that of a tabular format. So from this one, very simple. However, it's lengthy, and I believe this is not the best way to present this data. Okay, so if you are to use OLAP, So this is a two-dimensional view using OLAP. So you place all the quarters here and then the cities here, and then just match the corresponding amount of revenue to that of the quarter and the city. So it shows us a good glimpse of the same information that is being presented here in the table. This is way better, right? So this kind of information will be um, retrieved through the use of OLAP. This is an example of a three-dimensional view. So if you are to present this one in a tabular format, so um, sourcing from our first example, we add another column, which is your property type. So we have a flat. Flat is an English term for apartment. So flat house. Okay. And then if we are to convert this using OLAP, OLAP will show us this way. Okay, so it shows like a cube. It is presented like a cube. Okay, and then it has three dimensions. So this is the first dimension covering the cities, the second dimension on the property type, and then the third dimension regarding our quarters from quarter 1 to quarter 4. Okay, so like for example, if you want to know how much revenues did we earn from renting out a house in Glasgow. So in quarter 1, so we will have this information ready. Okay, so this is an example of a three-dimensional view of data using OLAP. So as you have noticed, in using OLAP, it's like showing data using a cube. Like instead of showing it in a tabular format, it looks like a cube. So we have this term data cube. Multidimensional structures, like the ones we have seen a while ago, are best visualized as cubes of data. So a cube represents data as cells in an array. Each side of a cube is a dimension. So as what I have presented a while ago, we have three dimensions, right? The first dimension being the city, the second dimension is your property type, and then the third dimension is your time, representing your quarters. Okay, so each side of a cube is a dimension. A cube supports matrix arithmetic. So we also have this hypercube. A hypercube is a form of data cube that has more than three dimensions. So if a data cube has more than three dimensions, we shall refer to it as a hypercube. So a hypercube can be represented as cube that contains cubes from other dimensions. So meaning cubes within cubes. As number of dimensions increases, the number of the cube's cells increases also exponentially. So this is another data cube example. This one is a three-dimensional data cube, right? So we have each side of the cube represents a dimension, correct? So we have three dimensions here. First dimension refers to your months, okay? And then another dimension refers to your product. And then another dimension refers to your stores or your branches or your outlets. So what are our different OLAP operations? So we have the slice operation, we have the dice operation, roll up or aggregation operation, drill down operation, and rotation or pivot operation. Okay, so what do we mean by a slice operation? So if you want OLAP to do a slice operation, that means that the system will select data on a single dimension of a data cube. Okay, select a data on a single dimension. So again, we have three dimensions a while ago, right? So if you do slice, just pick one dimension. So if you want the product dimension, so you will choose this one. If you want the month dimension, okay, if you want the month dimension, so you have to slice this one. Okay, if you want the store, um, the store dimension, so you have to slice this one this way. Okay, and then dice operation. This extracts a subcube from the original cube. So from a huge cube, let's break it down into different cubes, subcubes, and then just pick one subcube. That is dice. Okay, and then we have roll up or aggregation. This is the combining of cells for one dimension. So um, for example, the January, February, and March, we will add them all up. We will combine them and refer to it as quarter one. So in that way, we have actually performed a roll-up operation. So again, in roll-up, we will be combining we will be combining cells for one dimension. So that is why we also refer to it sometimes as aggregation, because you combine. So you get the total, okay, aggregate. And then we have the drill down operation. So this is the opposite of roll up in a sense that we, instead of looking at the total or the aggregate value, we will be looking at the data at level of greater detail. So instead of looking at it in a combined state, we want to break it down further so that we could look at more details coming from that data. So for example, we have a data on the northern Cebu, and then if you do drill down operation, you will break it down into the different municipalities or cities, like for example, Liloan, Danao, and Daanbantayan. And then the last operation will be pivot. So this will allow users to view data from a new perspective. So this is also referred to as axis rotation. Okay, so from our example a while ago, if you want to do slice, again, just pick one dimension. Okay, so this is slice, and then dice is when you get a specific subcube from the original huge cube. Okay, so here, diba, it's a huge cube. If you want to pick one cube, one subcube, that is a dice function. So for example here, um, you pick this cube, and this cube shows us the data on the sales of product A in store A on January 2005. Okay. And then roll up. Okay, in roll up here, you notice that the amounts are aggregated into quarter one. It doesn't anymore show January, February, and March. So this is roll up, aggregate already. But if you want to know the details, you want to drill it down. So drill down the quarter and then just show the months comprising such quarter. So that's January, February, and March. So that is drill down. And then this is rotation, axis rotation, or pivot. Okay, so if you can still recall the original data cube, diba, in this portion, what was shown are the months. And then in this portion, in this dimension, what was presented are the products. And then in this dimension, what was presented is your store number, store names. Okay, but this time we rotated it and had and was able to see another perspective or another view of the information. So that one is what we call a rotation operation, or axis rotation, or pivot. Okay, so in concept hierarchy, you could use this in your drill down function and roll up function or operation. So attributes may have concept hierarchies associated with. So for example, year. So for example, what was presented is a month, but if you aggregate those months, you can get a quarter. And if you aggregate all the quarters, then you will get a year, right? And same goes with drill down. If you are being presented with a year, you want to know more details of it, you can break it down into quarters. And then the quarters, you can also break it down further into months. Another example of concept hierarchy is with respect to a region. So a region is more aggregate. So if you want to break it down into more details, you can get provinces, and each province will be comprised of cities or municipalities. So that is what we call your concept hierarchy. Okay, and then the last topic we will discuss under OLAP are the types of OLAP tools. So OLAP tools are categorized based on how they store and process multi-dimensional data. So how they store, the process that we have to undergo in storing data and processing data, and as well as accessing or retrieving data. Okay, so we need not really understand all the um, technical knowledge regarding OLAP, because we are not information technology experts. We are management accountants, and or we are accountants. So the best thing for us to do is to understand the differences between these types of OLAP based on a simple yet understandable presentation. Okay, so the first type of OLAP is what we call multi-dimensional OLAP or MOLAP. Then the second one is relational OLAP or what we call ROLAP. And then HOLAP or hybrid OLAP. And then we have the desktop OLAP or DOLAP. Okay, so we have MOLAP, ROLAP, HOLAP, and DOLAP. Okay, so this is the OLAP architecture. So if you are here, you are using the computer, you are the end user, and you wanted to access or retrieve some information that is being stored in the database. So here in OLAP, instead of you directly accessing the database, we have here like a middleman, and that is our OLAP server. So um, if okay, when you want to access data coming from the database here, so the database will have to communicate with the MOLAP server, and it is the MOLAP server that will give you the result or the data that you want to retrieve. Okay, so again, we have this middleman, which we call the MOLAP server. This one is for rollup, relational. So when we speak of relational, it's like a tabular. It's like two dimensional OLAP. Okay, so it's somehow like an opposite of multidimensional OLAP, in that in multidimensional it has more than two dimensions. Here only two dimensions. So same goes with MOLAP here, wherein we have a middleman, which is the MOLAP server. Here, the ROLAP server also serves as a middleman. Okay, so if you want to access some data that are being stored in the database, so we have here the data request. Okay, but then from the ROLAP server, there is a need for the system to use the SQL or standard query language to communicate with the relational database server. And then the server will then give the result to the rollup server, which will then convert it to something, okay, and then give the result to you as the end user. For OLAP architecture, this is a mixture, hybrid man siya, no? So this is a mixture of multidimensional OLAP and relational OLAP. ROLAP plus MOLAP. That is your OLAP architecture. Okay, so it is using a MOLAP server here, but it is also using an SQL the standard query language. And then this is the OLAP. Lastly, this is the OLAP or desktop OLAP. OLAP architecture. So it is still using though OLAP server, and then it will be able to cater to queries of different end users using their own laptops. Okay, so how are they able to retrieve all information here simultaneously in real time? So this is the deployment of OLAP data from relational database or MOLAP server to desktop PC or a laptop using email, web, or traditional client server architecture. Right, so that ends our discussion on OLAP. And the last topics, which are your MRP, ERP, and TPM, will be discussed in a separate video. Thank you.